Hey guys, do subscribe and don't forget to hit that bell icon to be notified about our future videos. Mercury is the closest planet to the Sun, and that kind of makes it pretty hot. But still, it isn't the hottest planet in the solar system, and that makes it really cool. Speaking of cool, even though the temperatures rise as much as 400 degrees Celsius, there is still water ice on the planet. Unbelievable? It was unbelievable to us too. So let's talk about Mercury today. Hi, my name is Prateek and welcome to Anu Club. So as we have discussed, we have many neighbors, in our apartment building, of which 7 can be seen directly in the night sky without a telescope. Which neighbors, you ask? Well, there is the sun, of course, the biggest one. And then there is the moon, Earth's natural satellite. And then there are the planets. We can see Venus, also known as the evening star. We can see Mars, all huffed up and red. We can see Jupiter, since it's just so big. And also Saturn, rings and all. However, did you know that we can also see Mercury? That's right, even though it's the smallest planet and it's so close to the sun, we can still see it. All you need to do is look up straight at the sun. Wait, don't do that, I'm just kidding. You can hurt your eyes if you do that. But you can actually see Mercury just before sunrise or just after sunset, trailing the sun. Now, why is it called Mercury? First of all, Mercury is super fast, like really, really fast. It goes around the sun in just 88 days, while the Earth takes 365. So slow. And when the ancient Romans saw this, they decided to name it after the fastest god they had, namely the Roman messenger god, and you know who that is? Mercury. Now the planet also moves quite weirdly around the sun. It has the most elliptical orbit of any planet, which means the most oval orbit. But all planets have an oval orbit. And that's not weird in itself. What's weird though is that at its farthest point from the sun, Mercury is almost 2 times the distance from its nearest point. At its farthest, it's 70 million kilometers, and at its closest, it's 46 million. No other planet does this. And this means that when it's closest to the sun, it receives more than 2 times the light and heat than when it's at its farthest. Mercury is also a little strange since it is tidally locked to the sun. I know, tidally locked. It just means that one side of Mercury faces the sun at most times. And that is generally a right reserved for moons or natural satellites. But wait, that would mean that Mercury is kind of like a moon to the sun, and it's just about 1.5 times the size of Earth's moon. So is it a planet? Is it a moon? A planet moon? Anyways, we are all technically kind of satellites to the sun. So let's just move on from there. Because of this tidal locking, the way Mercury sees sunrises and sunsets is truly unique. The sun appears to move halfway across the sky, takes a break, goes back for a little bit, and then goes back on its original path. Kind of like a bouncing ball of fire in the sky. And this is also why a day on Mercury is really long. It takes almost 59 Earth days to complete 1 day on Mercury. And a year on Mercury is just about 88 days, which means that 1.5 days is equal to a year on Mercury. And during the day, it gets pretty hot there too. On the day side, the side facing the sun, temperatures rise to above 425 degrees Celsius. Phew! But I hear that the nightlife on Mercury is pretty chill. I mean, really chilled. The temperature on the night side, which is the side away from the sun, is about minus 173 degrees Celsius. Which means that the difference between the day side and the night side is more than 600 degrees. However, even in these harsh conditions, we have found evidence of water ice on one of the poles of Mercury. That's right, water ice. How is this possible? Well, Mercury has a lot of craters. I mean a lot. It is the most cratered planet in the entire solar system. I guess it's seen better times. So, in one of those craters on the north pole of Mercury, there's a small section which the sun never touches. It's kind of like in the shadows. These are called cold traps. Here, the temperature never goes above minus 173 degrees Celsius, even though the surrounding portions are far hotter. And this makes it possible for ice to exist. And more specifically, water ice, which is probably millions of years old, if not hundreds of millions. And scientists speculate that there may be a lot more water under the surface. We just don't know about it. Besides craters, there are also cracks on the surface of Mercury. These could have been formed basically because the planet just, dried out, it shriveled up, like clay that has been sitting outside for too long. Now, I have been mentioning again and again that Mercury is tiny, small, smallest planet, and so on and so forth. But how small is Mercury really? Mercury is just about 4,800 kilometers in diameter, about 1/3 the size of the Earth. And it doesn't have any atmosphere, which means that it gets the full blast of the sun's heat and radiation without a shield. The question is, how do we know any of this? Since Mercury is so close to the sun, it's difficult to observe it directly from Earth. So much of what we know about it is due to observations from space probes and satellites sent there. We sent our photographer friend Mariner 10, and it made 3 flybys of Mercury in the 1970s and mapped out about half the surface of Mercury. This is when we learnt about its, extreme temperatures, it's covered in craters, and that it has almost no atmosphere. In 2011, we sent our new photographer, the Messenger probe, and that entered orbit around Mercury after making a series of close flybys. By now, we had HD. So, the pictures that it took were breathtaking, were stunning, and it revealed so much more. We realized that Mercury must have taken a huge beating since there are craters pole to pole, some of them hundreds of kilometers across. But Mercury, I'm talking to you now. What you can take solace in is that even though you are the closest planet to the sun, you still aren't the hottest planet. And that award goes to...
The second home in the solar system building is Venus. Now, Venus is roughly the same size, density, mass, and composition as Earth. It's no wonder then that it's called our sister planet. Now, before Venus was properly studied, scientists and science fiction writers thought Venus would be exactly like Earth, home to lush tropical forests. In fact, Venus was often referred to as Earth's twin. However, this thought has changed in recent years with new observations that showed the surface temperature of the planet was tremendously high, close to 450 degrees Celsius, giving Venus the honor of being the hottest planet in the solar system. Take that, Mercury. Now there's a lot more to Venus than meets the eye. So a long time ago, Venus was one of the first planets that could be observed in the sky. It was initially thought of as a star, but eventually people realized that it wasn't. Since the invention of the telescope, people started learning more and more about Venus. Like the fact that it's really close to the Earth, just about 40 million kilometers away at its closest point, making it our closest neighbor. Once people realized that it was like Earth, they nicknamed it Earth's twin. And because it has a beautiful glow, they named it after the Roman goddess of beauty and love, the goddess Venus. You can even see Venus without a telescope. It can be seen early in the morning and late in the evening, shining brightly in the sky, earning the name of morning star or evening star. Don't let its name distract you though. Venus is nowhere close to a loving or beautiful planet. In fact, it's quite the opposite. So let's start with one of the key differences between Venus and Earth: Venus's spin. Venus rotates in the opposite direction to that of most other planets like Earth. Venus and Uranus are the only two planets that rotate clockwise. What that essentially means is that the sun rises from the west and sets in the east. Also, Venus spins on its own axis really slowly. I mean really slowly. And that makes a day on Venus very long. Exactly how slow is Venus? It's so slow that it takes 243 Earth days to complete just one day on Venus. Can you believe that? In comparison, a year on Venus, for Venus to take one revolution around the Sun, takes about 225 Earth days. So in effect, a day on Venus is longer than a year. All of this, of course, is just scratching the surface. Now, once we started missions to Venus, the first one being in 1966 by the Soviets, we started to see many more differences, each a little worse than the previous. Like on the actual surface of Venus, the differences from Earth are a little less subtle. First, there's the pressure. On the surface of Venus, the atmospheric pressure is huge, like 90 times that on the surface of the Earth. It is so much that the first few probes that we sent there just imploded due to it. And the stronger ones that landed later survived for just a few hours. It's like going underwater to about a kilometer deep. Even submarines don't venture that deep. They go to a maximum of 900 meters. Next, there's the rain. On Earth, rains are beautiful and life-giving. However, on Venus, the rain is essentially sulfuric acid. Yes, you heard me right, sulfuric acid. The clouds are thick, heavy, and really poisonous. But on the flip side, these acid clouds give the planet its characteristic and quite beautiful, dull orangish color. Moving on to its atmosphere, Venus's atmosphere is extremely rich with carbon dioxide. In fact, its atmosphere is about 96.5% carbon dioxide. You see, about 700 million years ago, just before life was diversifying on Earth, Venus experienced tremendous volcanic activity, and it still does today. This flooded the planet's surface with new lava and filled the atmosphere with greenhouse gases, namely carbon dioxide, causing a runaway greenhouse effect. Now let's get down to its science. Various wavelengths can pass through this invisible gas, but carbon dioxide is very effective at trapping heat. Light from the sun strikes the ground of Venus and warms it up. The ground tries to radiate the heat back into space, but the carbon dioxide traps much of it around the planet. This is why Venus is the hottest planet in the solar system, all thanks to carbon dioxide. We can learn so much from Venus because if we, back on Earth, do not keep our carbon levels in check, or any other greenhouse gas for that matter, we too shall end up like Venus. Scientists believe that a long time ago, Venus did not start out as Earth's evil twin. Actually, Venus was similar to Earth, with lower temperatures and even liquid water on the surface. At some point, billions of years ago, the planet started to heat up, and slowly all the water on the surface evaporated into the atmosphere. This brings us to the question, was there ever life on Venus? Well, there is evidence that when it was young, Venus almost certainly had liquid water, an essential ingredient for life on Earth. So now we ask, was Venus habitable in the past, and is it habitable today? Finding evidence of past life will be a big challenge. Massive volcanic activity caused resurfacing of 80% of the planet within the last billion years. But if someday we do get samples from the ancient surface of Venus, they could be very revealing. As for life on Venus today, some scientists speculate that single-celled organisms could actually survive within the harsh yet stable atmosphere, living off the sulfur present there. But for humans, it's still a long way off. Oh, and one final interesting thing to note. Under an international agreement, all surface features on Venus, like mountains, valleys, plains, and craters, are named after women or goddesses of various cultures. This is a homage to the planet itself being named after a goddess.
The next stop in the solar system building is the Earth, third one from the Sun. The Earth is a planet. You must be wondering why we're stating the obvious. You see, for thousands of years, planets were just bright lights in the sky. With the invention of the telescope, those dots of bright light became worlds, and with spaceships, they became places. The Earth went from being our unique home in the universe to one of many such, planets. The Earth is the largest of the terrestrial planets. Terrestrial planets. You know, the four smaller, denser, rocky worlds orbiting close into the Sun. Earth is about 12,742 kilometers across and has a single large moon which is tidally locked to the Earth. Unlike the other three terrestrial planets, Earth has something very important: water. That thing your parents keep telling you to drink more of. Earth is one of the only planets that has liquid water. Water that can flow around, evaporate, become clouds, rain down, and then mix up with chemicals so they can do interesting, complex things like support human life. Liquid water on the Earth's surface is unique among planets. The Earth's surface is about 70% covered in water. Earth's ability to sustain life depends on that water. It also depends on Earth's atmosphere, of course. Breathing has its advantages. Now take a deep breath and let's take a look. Like the sun, the Earth has many layers. To put it simply, they are the inner core, the outer core, mantle, and the crust. Let's start with the crust, the outermost layer of the Earth, or more commonly known as the area where we live. The thickness of the crust, Earth is not a pizza crust, ranges from 5 kilometers to 70 kilometers. The next layer is called the mantle, and it's much thicker than the crust, almost 3,000 kilometers deep. Let's go deeper to the outer core. The outer core is mainly made up of iron and nickel and is a liquid. And finally we come down to the seed of the planet, the inner core, the true rock star of Earth. The inner core consists of solid iron and nickel. The temperature in the Earth's core is tremendously high, reaching about 5,500 degrees Celsius, which, if you can imagine, is the temperature at the surface of the sun. The pressure is huge as well, as you might expect, with the weight of an entire planet sitting on top of it. Imagine all the elephants, buildings, cruise ships, and humans that the poor core has to endure. So another interesting thing the core does, specifically the outer core, is give the Earth a magnetic field we call the geomagnetic field. As previously discussed, the outer core is essentially liquid metal, which conducts electricity. This liquid moves, and in that motion, it generates magnetic fields. The overall effect it creates is similar to a bar magnet. The loops of magnetism that surround the Earth play a very important role. They create a kind of shield around the Earth and deflect most of the harmful stuff that comes from solar winds, like charged particles. Without this shield, solar winds would hit the Earth's atmosphere directly, and over billions of years, that would basically erode away Earth's air, water, and pretty much everything else. The magnetic fields or shields also produce a beautiful side effect called the auroras. They are colorful lights in the sky which occur close to the north and south poles. Speaking of shields that protect the Earth, at a height of about 25 kilometers is a layer of ozone called the ozone layer. Ozone is a molecule of oxygen that is good at absorbing solar ultraviolet light. Thus, the ozone layers create a second line of defense to prevent this harmful ultraviolet light from reaching the Earth. The Earth's atmosphere is made up of 78% nitrogen, 21% oxygen, and the remaining are gases, predominantly argon and carbon dioxide. Carbon dioxide is an important gas, even though it only constitutes about 0.04% of the atmosphere. Not that oxygen and nitrogen don't play a very important role. We wouldn't be alive if it wasn't for these two. It's just that carbon dioxide has a unique role to play. Time for some science. Sunlight hits the ground, which emits infrared light. If this infrared light were allowed to radiate into space, the Earth would cool. But carbon dioxide traps that kind of light, and the Earth doesn't cool as efficiently. This so-called greenhouse effect benefits the Earth. Without it, the average temperature on Earth would be below the freezing point of water. We'd be an ice ball, a very useless ice ball. This is why climate scientists are concerned about carbon dioxide. A little is a good thing, but too much can be dangerous. Since the Industrial Revolution, we've added a lot of carbon dioxide to our atmosphere, therefore trapping in more heat. By every measure available, the heat content of Earth is increasing, upsetting the balance. It's melting glaciers in Antarctica and Greenland, as well as sea ice in the North and South Pole. Sea levels are going up, and some of the extra CO2 in the air is being absorbed by oceans, acidifying them. The Earth is the only planet that has so far supported life, and you know what? Maybe we should keep it that way. But in case we don't, our get out of jail card is Mars.
The thing is, I am a science fiction guy. From when I was a kid, I've always been fascinated by aliens and the future. So while growing up, Mars played a very special role in my life. You see, in zillions and zillions of books, movies, and TV, Mars is home to thousands of adventures, invasions, and wars. But now that we have gone in its orbit, landed, and roved there, it's become far more than a simple background for an alien invasion story. It's become a world, a place, and maybe, one day, a destination. Hi, my name is Neil, and welcome to Mars. Okay, so I'm just going to meteor shower you with a whole bunch of facts about Mars. The point is to introduce you to it, so why not just give you the cheat sheet? Mars is the fourth planet from the Sun and the outermost of the terrestrial planets. That is, the ones that are rocky and similar in size to Earth. It orbits on average a little more than 200 million kilometers from the Sun. That puts it outside Earth's orbit, and it never gets much closer to us than about 60 million kilometers. It's colder than us too, with an average surface temperature of about 60 below 0 Celsius. That's cold. So the thing is, Mars isn't a terribly big planet. It's only about half the size of Earth. Still, when it's closest to us in space, it shines brightly in our night sky. So it turns out Mars isn't red because it's bloody. It's red because it's rusty. Literally. That red color you see comes from really fine dust on the surface, almost like talcum powder. The dust is rich in iron that's oxidized, and it's basically, well, rust. The dust coats a lot of the surface, giving it a deep brown-red look, which also gets blown into the atmosphere. A lot of the surface of Mars is also grey volcanic rock called basalt, and together with other minerals gives Mars its overall reddish look. We can get a decent view of Mars from Earth using telescopes, but small features are very difficult to see. Like little dots on a comic book print, they're present, but you can't see it unless you look closely. The idea of a beautiful and calm environment on Mars stuck with us because of so many stories. You know, science fiction and fantasies, at least until the 60s and 70s when we started sending probes to the planet. But when we finally did land the first rover on Mars in 1997, we did not see a lovely habitable world. Instead, what we got were photos of a dry, dead, forbidding planet. The surface of Mars is weird. There's a huge separation between the northern hemisphere, which is mostly smooth plains, and the southern, which is cratered, hilly highlands. Apparently, Mars suffered a tremendous impact from an object hundreds of kilometers across ages ago. It left behind a vast crater near the north pole of the planet, which soon filled with lava. Another large feature is the Tharsis Bulge, a huge plateau that's home to the 4 biggest volcanoes on Mars and the largest volcano in the entire solar system, Olympus Mons. But the grandest of the surface features on Mars is easily, bear with me here, Valles Marineris. It's a gigantic crack in the surface of Mars, 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep. That's 10 times longer and 10 times wider than the Grand Canyon. Also, unlike the Grand Canyon, it wasn't carved by water. It may have formed when the Tharsis volcano rose up, creating the valley as a radial crack in the surface. I don't know about you, but from the outside, it just looks like a massive red ball that my cat clawed. Mars, like Earth, has polar ice caps. Yes, you heard me right. There is water ice on Mars. Well, mostly water ice, several kilometers thick, like Antarctica, but still surrounded by tons of dust, not water. These caps get seasonal coatings of dry ice, that is, frozen carbon dioxide that covers them from 1 to 8 meters thick. This happens in their respective winters. In the summer, sunlight warms up the CO2, turning it directly into a gas, which then blows away from the poles, generating fierce wind. Speaking of which, Mars has an atmosphere, but it's super thin. Pressure at the surface is less than 1% of the Earth's, and the air is mostly carbon dioxide. In fact, as much as a third of the Martian atmosphere freezes out every winter to coat the polar ice caps. The air doesn't provide much of a shield from asteroid and comet impacts, so the surface is heavily cratered, and it still gets hit today. So the space probe Mars Reconnaissance Orbiter has been circling Mars for so long, it actually sees new craters and fresh impacts on the surface of Mars. But this thin atmosphere makes it difficult for rovers and other spacecraft to land because they don't have enough air to let the parachutes work. So scientists are constantly developing new and interesting ways to land there safely. Once they do and mankind lives there, we would have sunsets that aren't orange or red, but blue. Not just this, mankind will not only have blue sunsets, but we will witness 2 moons. Yes, Mars has 2 moons. Small potatoes just circling around the planet, unlike the cheese that revolves around our Earth. They're called Deimos and Phobos. Both are tiny. Phobos is about 25 kilometers across and Deimos just 15. Both look very much like asteroids and may indeed have been captured by Mars from the nearby asteroid belt. To be honest though, it's not clear what their origins are. Phobos orbits Mars only 6,000 kilometers over the surface. In contrast, the moon from your window is 3,84,400 kilometers. Phobos in ancient Greek means fear, and rightly so, because of this pull from Mars. You see, Phobos is getting slowly closer and closer to the surface, and in a few million years, it's expected to drop low enough to actually enter the atmosphere and impact the surface. And that'll be really exciting to watch, from a safe distance, of course. Meanwhile, Deimos is the outer moon. But unlike Phobos, the fate of this moon is devastatingly lonely. Though the moon is currently attracted by the gravitational pull of Mars, it is slowly going away from it, and eventually it shall wander into an empty space. So we know that Mars has rocks, air, weather, and volcanoes. But what about water? If it has frozen water at the poles, what about the rest of the planet? Well, there are traces of water ice in the mainlands. Some recent meteorite impacts have white around them. They are underground deposits of ice splashed out by the impact. But there is still no strong evidence of flowing liquid water. Sometimes crater walls collapse a bit and have dark channels running down them, which look like they could have been carved by flowing water. But there are other ways to explain this too, so their cause isn't exactly certain. But in the past, things were very different. We know that Mars was once very wet. There is a lot of evidence for flowing water on the surface long ago, including dry riverbeds, dry lakes, sedimentary layers, and minerals that we know need water to form. There's even evidence that Mars once had oceans, but that's all gone now. What happened? It isn't clear yet. Billions of years ago, Mars was almost certainly warmer and had a thicker atmosphere. But for some reason, its internal dynamo just shut down and its magnetic field disappeared. See, this left it vulnerable to solar wind. And over billions of years, the Martian atmosphere was eroded away and the water went with it. That raises another obvious question. It had air, it had water. Could it have had life? See, that is the question that is bothering scientists and people alike. Enough bother that there have been constant efforts to send probes to Mars to look at what conditions for life are like now and how they were in the past. It is still an open question. And we know that life on Earth got its start not long after the surface cooled. Mars is smaller and cooled more quickly after its formation. So it's not crazy at all to wonder if life formed there. Maybe even before it did here. Interestingly, the Curiosity rover detected simple organic molecules in a rock sample. Now, this doesn't mean that there is life there, but it means that the ingredients were and possibly still are there. It also detected a brief spike in methane, a volatile gas that can be produced by life, as well as other geological processes. The evidence that we have right now is mind-numbingly vague. I know, but we're just starting out. Give it some time. Mars is not the planet it used to be. But that doesn't mean it's off limits. You see, getting to Mars is hard. Over half the missions that have been sent there have failed. But it isn't impossible. We've had amazing successes, including orbiters, landers, and rovers. I'd say that over the past 2 decades, we have learnt more about the red planet than all the centuries that we've been studying it. And yet, all we've sent are robots. Now, robots are good and relatively inexpensive, but they are slow. They can only cover so much ground. A human could do as much in a week as a rover could in years. But humans are also fragile. We need water, air, food. We aren't terribly tolerant to, radiation or vacuum. But the idea of sending people to Mars isn't as nuts as it might have been once. We are making better rockets and have already started building the tech needed for human exploration of Mars. We can't say when this will happen. 20 years from now, maybe 30, maybe more. But it will happen. Eventually, there will be life on Mars. And it's going to be us. I hope you had fun at Anu Club this time on Mars. Next time, big fat Jupiter.
And while you're here, don't forget to like, share and subscribe, and do press that bell icon to be notified about our future videos.